Good day everyone, you're welcome to my YouTube channel and I am Cyrx. So on today's class we'll be looking at the inverse of a function, and these are going to be what we'll be going through, right? So from question number 1 down to question number 4, we want to find the inverse of this function. Okay, so for question number 1, f of x equal to 3x plus 2 all over x minus 1, right? So what we are going to do, our aim here is to make x subject of the formula, to express the equation in terms of x, right? So we know that f of x is y, so we'll replace it with y, right? So y is equal to 3x plus 2 all over x minus 1, right? So we want to make x subject of the formula. If we cross multiply, we have y into x minus 1 equal to 3x plus 2. So this is x y minus y equal to 3x plus 2. So we can collect like terms and our 3x move over this way. So this becomes xy minus 3x equal to 2 plus y, right? Moving the y across the equality sign, from negative it becomes positive, and the 3x across the equality sign, from positive it becomes negative. We can factorize here. Okay, so this is x into y minus 3 equal to 2 plus y. So at this point we can divide 2 by y minus 3 to make x subject formula. By doing so we have x, okay, we have it this way, y minus 3. So we are left that x is equal to 2 plus y all over y minus 3, right? At this point what you need to do is just to interchange the variables. Wherever you see x, put y, and wherever you see y, put x. So here is x, so change it to y, right? So this becomes y equal to 2 plus, this is y, right? We change it to x, so x divide, this is y, we change it to x, so x minus 3, and this is actually the inverse of the function. Okay, this is actually your inverse function. Meanwhile, we move to question number 2. Let's see how we do that. For question number 2, given that y is equal to ln of x minus 2, what do we do? I would rather prefer writing it this way. So ln of x minus 2 is equal to y. Remember, our objective is to make x subject formula, right? So taking the logarithm of both sides, this will be x minus 2 equal to e raised to the power of y. Taking the exponential of both sides, it will give us that x minus 2 is equal to e raised to the power of y, right? And x is equal to e raised to the power of y plus 2, moving our 2 over here, right? And having been able to make x subject of the formula, the next step is to interchange the variables. Anywhere you see x, put y, and everywhere you see y, put x. So this becomes that y is equal to e raised to the power of x plus 2. And this is our inverse function. This is the inverse function of what we have there, right? Okay, so we'll be attempting question number 3. I'll write it this way. So it will be, okay, y equals to log, this is question number 3, base a for x plus x squared plus 1. Taking the exponential of both sides, we have that e raised to the power of y, a raised to the power of y A will carry this as a power. A raised to the power of y is equal to x plus x squared plus 1. Okay. Remember what's our objective? We want to make x subject formula. We want to make x subject formula. Okay. Raised to the power of y minus x is equal to square root of x squared plus 1. So at this point, you can take the squares of both sides. So we can eliminate these square roots, right? So taking the squares of both sides, we have a raised to the power of y minus x squared is equal to x squared plus 1, right? And by expansion, we have this to be by expanding this, this is like something of like this, say right, something of that nature. So by expanding that, we have a raised to the power of 2y minus 2x a raised to the power of y plus x squared, okay, then equal to x squared plus 1. At this point, taking like terms, x squared minus x squared becomes 0, right? So we have that a raised to the power of 2y, okay, minus 2x a raised to the power of y is equal to 1. Making x solid formula has always been our objective. So we move this way, a raised to the power of 2y, this way, minus 1 equal to moving this way, 2x a raised to the power of y. To make x stand alone, we divide all through by the coefficient of x over the right hand side. And what are the coefficients of x? 2a raised to the power of y. So we divide through by 2a raised to the power of y. And we get this. Right? So this cancel out this. So we are left with okay. So we are left with a raised to the power of 2y minus 1 over 2 a raised to the power of y is equal to x. And what do we do at this point? Now that we've been able to make x equal to the formula, we just interchange the variables, right? Everywhere you see x, put y, and everywhere you see y, you put x. So this becomes a raised to the power of 2x minus 1 all over 2 raised to the power of x equal to y, right? We could actually simplify this. Let's do that over here, right? Let's do that over here. A raised to the power of 2x all over a raised to the power of x minus 1 over a raised to the power of x. Because what we have here is common denominator. 2 is common denominator, right? So by indices, we are going to have here a raised to the power of x, here is a raised to the power of 2x. So if we divide, we have 1 over 2 here, a raised to the power of x minus 1 over 2 a raised to the power of x equal to y. 1 over 2 is common, so we can factorize it out. Since 1 over 2 is common, we can factorize it out, leaving us with a raised to the power of x minus 1 over a raised to the power of x equals to y, right? We would also do something to this point by indices. So this becomes 1 over 2 a raised to the power of x minus a raised to the power of negative x is equal to y. And this is actually the inverse of the function. That's the inverse of the function. So we'll be taking our last question. And I'll just quickly do that here. Our last question. That's good. So, okay, so for our last question, we said y is equal to 5 raised to the power of log of x, right? So taking the logarithm of both sides, we have that log y will be equal to log x log 5, right? And okay, so by logarithm, so we can, our aim is just to make this to the formula. Now to divide 2 by log 5 so that we can have log x standing alone, this becomes log y divided by log 5 is equal to log x. Yeah, and at this point we want to do something very technical, something very technical. Log y all over log 5. Yeah, I want to transform it to something very beautiful. This will actually give us log of y raised to the power of 1 all over log of 5. So it is definitely equal to log x, right? How is that true? You know, this is logarithm, and one of the laws of logarithm says that log of x is the power of n will be equal to n log x. So having log of y is the power of 1 over log 5, we can have this to be 1 over 1 log 5 log y. Have it to be like this. So from that law, have it to be 1 log 5 log y, right? And this is having now log y divided by log 5, which is actually what we have here, right? So that's how we brought that out. So at this point you can cancel the logarithms. Okay, so you have that x is equal to y raised to the power of 1 all over log 5. Now, having been able to make x subject to the formula, you do what? Interchange the variables. So we have that y is equal to x raised to the power of 1 all over log 5. And this is our final answer. Of course, if you find this video helpful, like, subscribe, and then share it with your friends. Up until I come again, thank you.